So now we're on the next page. So for number 15, these are actually easier to go from scientific notation to standard form. So we start out with 6.38, and then it says times 10 to the third, so that's times 1,000. So that will move the decimal point 3 times to the right. Notice that I filled in here, kind of looks like I was circling the time sign, but I filled in here, we needed a placeholder 0. So 6.38 times 10 to the third is equivalent to 6,380. For number 16, we're multiplying times 10 to the fifth, so that's going to move the decimal point 5 times to the right. We'll need to add 2 placeholder zeros, and so that is equivalent to 208,500. Number 17, we only have to move the decimal point once, so we move it in between the 8 and the 2, so it is 98.2. Number 18, let's see, we have to move the decimal point 6 places to the right. We'll need to add 3 placeholder zeros, so we get 5,388,000. Number 19, since 10 to the second, we'll move the decimal point 2 times, so it's 821. Number 20, now we're dealing with negative exponents, so the number's going to get smaller, so we need to move the decimal point 5 places to the left. That means that we'll need 4 zeros in front of the 5 before the or after the decimal point, and before the 5, and so it would be 525 10 millionths, or 0.0000525. Number 21, we need to move the decimal point just once to the left, so it would be 0.7932, or 7,932 10,000ths. Number 22, we need to move the decimal point 7 times to the left. And be careful when you fill in those placeholder zeros. If we move this decimal point 7 times to the left, we only have to put in 6 zeros, because notice that first move that we do from here to here, that doesn't require that we add a 0. So writing that in standard form would be 162 billionths. Number 23, it says we have to move the decimal point 9 places to the left, which means we'll need to fill in 8 zeros there. And so we get 24 10 billionths. And number 24, we need just to move the decimal point just twice. And so we get 6,018 hundred thousandths. All right, number 25 through 28, they're asking us which numbers are bigger. So if you look at 25, 7 42 hundredths times 10 to the third. Well, 10 to the third is 1,000. So we're multiplying like about 7 times 1,000. And 10 to the fifth is 10,000. So even though 7 is bigger than 3, we're going to multiply 7.42 times 1,000 versus 3.128 times 10,000. So obviously, so the one like on the right is closer to like 30,000, while the one on the left is close to like 7,500. So obviously the second one is bigger. For 26, so really like comparing the numbers, it's pretty easy when you look at the the powers of the tens, right? So here, 10 to the 7th obviously is way bigger than 10 to the 4th. 10 to the 7th is 10 million, while 10 to the 4th is only 10,000. So obviously, if you multiply a number times 10 million versus 10,000, it's good, and it's a they're both single digits. Obviously, the first one is the bigger one. Now, for 27, this takes a little bit more thought because we're talking about negative numbers. So, in terms of negative 3 is actually smaller than negative 2 because it's further left. So for 27, 10 to the negative 2, that's the same thing as 1 over 10 squared, or 1/100th. And 10 to the negative third, that's 1 over 10 to the third, or 1/1000th. So when we multiply by 1,000th versus 100th, multiplying by 1,000th will make the number even smaller. And so the larger number is the first one. And then 28, the other thing you could do to compare these obviously is write them in standard form and then just compare them in their decimal form. And then 28, 10 to the negative 6 is way smaller than 10 to the negative 1, so the larger one is the one with 10 to the negative 1 as a factor. All right, and the last part, the applications. For number 29, they just want us to rewrite that number of seconds in scientific notation. So we just have to count up how many times we move that decimal point, and it is 15 times. So it would be 2 times 10 to the negative 15th seconds. And the last one, they give us the distance from the Earth to the Sun and the Earth to Mars. They ask us which one's closer and by how many miles. So obviously Mars, if it's Mars is the further one, or it's the larger number there. So if we write them both in standard form, the distance between Earth and Mars, Mars and the Sun is 228 million miles, and from Earth to the Sun is 93 million miles. So if we subtract those two, we get 135 million miles. So Earth is closer by 135 million miles, or they wanted it in scientific notation, 1.35 times 10 to the 8th miles. Great job.